رحيم أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة هناخد درس جديد في الجبر اسمه خواص المحددات أو تابع خواص المحددات ومسائل عليها. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in algebra. It's titled Follow of Properties of Determine. Follow of Properties of Determine. Dear student, look at the first example. Without expand, prove that determinant has 3 row and 3 column. The first row 0 KL, second row negative K0M, third row negative L, negative M, 0 equals 0. Dear student, without expand, prove that. How to prove that any determinant equals 0? By use more method to prove that equals 0. Why? Because if the 2 rows are equals or 2 columns are equals, the determinant equals 0. If the diagonal must be equal numbers without 0 and all elements equal 0, all elements equal 0, answer is equal 0. KLM are any values. Solution. Dear student, by taking negative 1 as a common factor. Why taking negative 1 from first row, second row, third row? What you deduce? Determinant is negative 1 multiply determinant the first row 0 negative K negative 1 negative K negative L K0 negative M L M 0. Change the row and the column, then determinant negative 1 multiply brackets. After could change the all row and columns. Look at the first row becomes 0 KL, second is negative K0M, third row negative L, negative M 0. Equals what? Equals negative 1 times D. What you deduce, dear student? In this case, negative 1 multiply negative multiply determinant. The determinant D, then we deduce that 2D equals 0. Why? Because equation D equals negative D. By using the addition inverse, then 2D equals 0. In this case, D equals what? The determinant must be equal 0. Dear student, in this example, after taking negative 1 highest common factor, then the determinant is 0 negative K negative L K0 negative M L M and 0. After that it change the row and the columns, then when it change or after it change row and the columns, we find the determinant after change must be equal the determinant D. In this case, D equals negative 1 times D. After that we put the equation as 2D equals 0, then the determinant equals or must be equal 0. Then without expand, we find the value of D equals 0, or we prove that the determinant without expand equal 0. Look at, dear student, any determinant if all elements of any row or column are written as sum of 2 elements, then the values of the determinant can be written as the sum of the two determinants. Example. This example about the second property. If we have determinant a dx plus 1 in first row, b e y plus m second row, c f z plus n third row, we can divide the determinant into two determinants. The first is first column a b c, second column d e f, third column x y and z, plus the same first column a b c, second d e f, second column, third column 1 m and the n. Then this is property very important. We can divide it any determinant by two determinant. The first row, the second row are same, but the third row we divided it x plus 1, x in the first, 1 in the second. Y plus m, y in first, m in the second. Z plus n, z in the first, n in the second. Example. Expand using the factors of second row. D3 equals 1, negative 2, 3 first column, 0, 4, negative 1 second column, negative 2, 3, 5 in third column. Solution. Let us the second row by using second row negative 2 multiply its cofactor determinant. What is the cofactor determinant of negative 2? Second row a to 1. We removing the first column with the second row, the determinant is 0, negative 2, negative 1, 5. We multiply negative 2 multiply determine 0, negative 2, negative 1, 5 plus 4 multiply its determinant 1, negative 2, 3, 5 negative 3 multiply determinant 1, 0, 3, negative 1. Remember, dear student, the sign of the second row is negative, positive, negative. Answer is 2 multiply 0 times 5 minus bracket contains negative 1 times negative 2 plus 4 multiply 1 times 5 minus negative 2 times 3, negative 3 multiply 1 times negative 1 minus 3 times 0. Answer is 2 times negative 2 plus 4 times 11, negative 3 times negative 1. Answer is negative 4 plus 44 plus 3 equals 43. Solve the equation. The first row x plus 2x plus 1 0 negative 1 2 x plus 1, the second element, second row, or elements in the second row, elements in third row 0 6 3x equals what? We find the value of the determinant by using element of the first row. We multiply first x multiply bracket contains 6x minus 6 multiply x plus 1 and the negative 1 multiply 2x plus 1 minus 3x negative 0 plus 0. Answer is equal 0. Then we find the equation negative 6x plus 6x power 2 plus 3x equals 0 by taking like terms. Then the equation becomes 6x power 2 minus 3x equals 0. Taking highest common factor 3x, Then 3x multiply bracket 2x minus 1 equals 0. In this, x equals 0 and x equals what? X equals 0 and x equals 1 over 2. Why? Because 2x equals 1 or 2x negative 1 equals 0. The value of x in this case, x equals 0 and x equals 1 over 2. Solve. What you mean of the solve? Find the value of x. Dear student, we have determined, we have elements, and one of two unknown is x. When expand this determinant by using second row and determinant equals 0, find the value of x by using common factor 3x multiplied 2x minus 1 equals 0. Each term equals 0. 3x equals 0 means x equals 0. Second bracket equals 0 to x minus 1. Then 2x equals 1. Then x equals 1 over 2. If we solve solution set, x equals 0 or x equals half. Another example. If omega is one of cubic roots of 1 and I imaginary number square root negative 1, prove that this equation determinant, look at determinant, prove that determinant 1 I omega I negative omega 0 omega square I negative omega square plus third element omega equals 0. In this case, we find the value of omega. Remember, what is the I? I is imaginary number square root negative 1. Square root negative 1 is I square equal negative 1, I power 3 equals negative I power 4 equals 1. But what is the relation between omega? Omega and 1. Omega is one of roots of cubic root of 1 of unity. Remember, 1 plus omega square equals 0. Then 1 plus omega equal negative omega square. Or 1 plus omega square equal negative omega. Then omega power 3 equals 1. Remember, omega power 3 equals 1. Why? Because 1 is unit. Cubic root of 1 is 1. Omega power 3 equals omega, but omega plus omega square equals negative 1. Remember, I is called a measure number from complex number x plus iy. What is the I? Is square root negative 1, and we know I square equal negative 1, but I power 3 negative I and I power 4 equals 1. Remember, dear student, now we solve this example by all properties of imaginary number and the omega. Dear student, determinant equals taking on common negative omega by factorization, expand the first one, multiply its determinant, negative omega 0, negative omega square omega. Negative I multiply determinant, omega I 0, omega square I omega. Plus omega square multiply its determinant, omega I negative omega, omega square I negative omega square. By using cross multiplication in determinant, look at 1 multiply its determinant. What is the determinant value? X and student, negative omega times omega, negative omega square, minus negative omega square plus omega square equals 0. After that, I multiply its determinant, omega I times omega, omega square I minus 0 plus omega square multiply omega I multiply negative omega equal negative omega power 3I minus negative omega power 3I. look at the determinant after expand equals negative omega square negative 0 in the first, negative I multiply bracket contains omega square I negative 0 plus omega square multiply bracket contains negative omega power 3I plus omega power 3I. After that, answer is negative omega square I plus omega square times 0. Then the answer is negative omega square plus omega square. Answer is equal 0. Now we are translate to another example. Look at 2, 5, negative 1 first row, 0, 3, 4 second row, 0, negative 2, 1 third row equals 2, 5, negative 1, 0, 3, 4 second column, 0, negative 2, 1 third column. The value of determinant is unchanged by expand its term of the element of any of each row or column. Remember, the second property in the value of determinant is unchanged when by using expand at when the elements of any row or any column are changed. Let D3 determinant 3 column and 3 row, 3 negative 5 9 1 2 negative 4 4 0 0 using first row. Then determinant is 3 multiply 0 minus 0 plus 5 multiply 0 negative 16 plus 9 multiply 0 negative 8. Answer is 80 negative 72 equals 8. Using third column, 9 also equals 8. Then by using third column, we find the value of determinant by expand of third column equals the value of when use the first column. When change all elements of row and column, the answer is not changed. The first value is equals 8. The second value is equals 8. Then what we deduce? Excellent student. If we change the first row with the first column, when expand the determinant, is the value is change, is not a change or unchanged. Okay. Third one, if two rows or columns of determinant exchange their position, the value of the resulting determinant equal negative the value of the original one. Example, look at, dear student, prove that determinant have 3 row and 3 column. First row BC A square, second row CA B square, third row ABC C square equals 1 A square A power 3, 1 B square P power 3, 1 C square C power 3. By multiplying first row by A, second row by B, third row times C in determinant of left hand side and dividing by A, B and C. Remember, dear student, we multiply the first row by A, second row times B, third row times C, then we divided by A, B, C. When multiply A times B times C and divided by A, B, C, then what did you use? The determinant not change. Then by multiplying the first row by A. Look at, we divide by ABC means we multiply by 1 over ABC, and the first determinant multiply the first by, look at A. The determinant becomes, the first is ABC, A squared, A power 3. Second row, ABC, B squared, B power 3. Third is ABC, C squared, C power 3. What did it use? We have ABC common factor in the first row. Taking ABC by using ABC common factor, then left hand side equals ABC over ABC, multiply first column 1, 1, 1, second column A square, B square, C square, third column A power 3, B power 3, C power 3. Then what is it use? Equals right hand side. Why? Because A over ABC over ABC equals 1. Then left hand side equals right hand side. Remember, dear student, the first we multiply the first by A, the second by B, third by C, and divided by ABC. After that, taking highest common factor ABC, divided ABC, we find the determinant in right hand side, 1, 1, 1, first column, A square, B square, C square, second column, A power 3, B power 3, C power 3 in third column equals right hand side. Dear student, if the two rows or column of determinant exchange their position, the value of resulting determinant equal negative the value of the original one. Determine, dear student, position of the value when change the resulting determinant equals the negative of the original one. Example, prove that determinant BCCA equal AB over ABC, A power 2, B power 2, C power 2 equals what? Equals 1, 1, 1, A power 2, B power 2, C power 2, A power 3, B power 3, C power 3. We know that if we multiply the first by A, second by B, third by C, and taking the highest common factor, ABC, and when divided by ABC, the proof is required. Look at the first is and left hand side is, then the left hand side must be equal right hand side. But this example, by using Cramer method to find the solution of the following equations. The first, x plus 2y plus z equals 3. Second, 4x minus y negative z equals 6. Third, x plus y plus 3z equals 10. By using Cramer, we find the delta, determinant of coefficient of x, coefficient of y. What is the delta? 1, 2, 1 in the first row, 4, negative 1, negative 1, second row, 1, 1, 3 in third row. We find determinant of the delta by using element of first row or second or third or by more method. There are method of first row or by using elements of the column of the third method by using diagonals. What is the meaning of the diagonal? We have the delta 1, 4, 1, first column, 2, negative 1, 1, second column, added the first and the second column. After that, connect the elements of the original diagonal 1, negative 1, 1, negative 1, 3. After that, by using the second diagonal, third diagonal, then add, after that subtract from the reflex diagonal, we find the delta equals negative 23. After that, by using delta x, change the coefficient of x by the absolute value. Delta x is 2 to 1, 6, negative 1, negative 1, 10, 1, 3. Answer is negative 46. By using delta y, the change of the coefficient of the second determinant becomes 1, 3, 1, 4, 6, negative 1, 1, 10, 3. Answer is 23. By using any method to determine or to find the value of delta y. Remember the value of determinant by using row, by using column, by using diagonal. And we have many properties to find or to expand the delta y or the determinant value by more methods. We have more methods to find the value of delta y by using properties of determinant. After that, delta y equals 23, then find the value of delta a z. Delta z equals what? Change of the third by using coefficient of z, by using coefficient of absolute values, then delta z equals 1, 2, 3, 4, negative 1, 6, 1, 1, 10. We find the value of delta z negative 69, then find the value of x, delta x over delta equals negative 46 over negative 23 equals 2. Also y, delta y over delta, 23 over negative 23 equals negative 1. Z equals delta z over delta equals negative 69 over negative 23 equal 3. Then the solution set of x, y, and z to negative 1, 3. This method is very important to use determinant to solve three equations of three unknown values x, y, and z. If we have three unknown, this is a system x, y, z, three unknown variables, and we find the value. We need the equations x, y, and z to solve two equations. We need, if we find two unknown variables as x, y, we need two equations. But if we have three unknown as x, y, z, we need the three equations to find the value of x, y, and z. By using determinant, we solve any equation as the matrices. Don't forget, matrices as determinant is a system, has row and has column. Also determinant has row and has column. Dear student, determinant is system of equations of elements which has row and which has column, and we know properties of determinant as 8 or 9, the 8 or 9 properties to find the value of determinant, how to prove that determinant equals 0, how to find or to prove that the value equals 0 without expand the determinant. All properties is very important in determinant. And after we know that increases lesson in this year is matrices, very important also is matrices is application about determinant. Then by using this method, we find the value of x, 2, y equals negative 1, z equals 3. When substitution about x, 2, y equal negative 1, z equals 3, must the equation are satisfied in 3 equations. Dear student, by the end of the lesson, we know determinant and its properties. Dear student, I am very happy to spend such time with you. Don't forget, math simple think work with you. Goodbye.